Jai Gurudev. Good morning, student. Today we are starting classification of crystalline solid. So, classification of crystalline solid. So, crystalline solid actually classified into three parts. Actually, it is four parts. One is your molecular crystalline solids, ionic solids, metallic solid, covalent or network solid. Now, this molecular solid subdivided into some part. So this is A, B, C, D. So we have two molecular solid. Number one is non-polar molecular solid. Non-polar molecular solid. Represent that one by MS. Non-polar molecular solid. If the non-polar molecule becomes solid, for example H2, Cl2, I2. Now this is non-polar. I non-polar. Why? Because the electronegativity of this one 2.7, this one also 2.7. So both will attract one another with the same force. So that is become non-polar molecular solid. So second one, polar molecular solid. Polar molecular solid. So in that one definitely having some pole in it. For example HCl. HCl means H positive, Cl negative. Why this is so? Because it is 2.1, Cl is 3.0. So Cl will take more electron towards it, the negative, this is positive. So polar molecular solid, if these things become polar, so it is polar molecular solid. In this one non-polar, this is your van der Waals force of attraction applicable in this one, or London force you can tell that, and this one is dipole interaction. Next one is your H bonded molecular solid, hydrogen bonded molecular solid. So in hydrogen bond actually you have to remember Vodafone word. So anything contains fluorine, oxygen, nitrogen, that one forming hydrogen bonding. So non-polar molecular bonding, for example HF, H2O, NH3. So when these become solid, we know that solid form of water is ice. These are called your hydrogen bonded molecular solid. So the force of attraction in this one van der Waals force, this one dipole interaction, and this one is force of attraction is your hydrogen bond. Next one that we are going to read, this one is ionic solid. So obviously the word cell ion in example is NaCl, Na positive, Cl negative. Though in which the solid constituent particles are ions are called ionic solid. Here they having the strong Coulombic force of attraction. force of attraction, or you can tell that interionic force of attraction. So this is the strongest actually. In ionic solid, the force of attraction is strongest. So they do not conduct electricity in the solid state because the ions just vibrate in their own position, but they conduct electricity in the molten and liquid state. That part remember this because this is required. Conduct electricity in molten or in aqueous solution, but at solid state they do not conduct. So after this we have metallic solids. Metals are the constituent ions. So you can see that one, if the metal is there, for example metal is sodium is there, so sodium becomes sodium positive and give out its outermost electron. These are called your kernel, and they are in the sea of electron. So this is called electron sea model. So more the number of electrons available outermost shell, more stronger is the bonding. But the metallic solid, one of the important point is that the different metallic solid from the ionic solid is that metallic solid conduct electricity in solid state due to the flow of electrons. Electrons can easily flow, but due to the flow of electrons, metallic solid can conduct electricity very smoothly. Another point is that about your ionic and metallic solid, you remember on heating ionic solid conduct electricity faster, and on heating metallic solid conduct electricity at slower rate, because on heating what happens, this kernel starts moving like that, and this positive charge retards the flow of electron. But in your ionic solid, more number of ions generate, flow of ions takes place due to heating. The last part in this one, you have to require to read about your covalent or network solid. So covalent or network solid, actually if you have this is the structure of diamond. This giant structure takes place. So this is your covalent solid. This one again you draw 3 3 3. So this one is going on, and another one, this is first one is diamond, another one is graphite. Graphite structure is like that. So you see that this is the layers after layers. So one layer can slide over the other layer. In diamond structure, carbon having how many electrons? Carbon is 2, 4 electrons. All the 4 electrons of carbon involved in bonding. So this is a bad conductor of electricity. that become that conductor of electricity, and this is carbon but there is 3 electrons are involved. It is good conductor of electricity. And another one, graphite can slide over one layer of the other because due to the weak van der Waals force of attraction among the layers of the graphite molecule. So these are the examples, and student, you try to remember the examples of all types of solids there. What are the examples of covalent solid? So covalent solid, some examples are there. For example, SiO2 is covalent solid, SiC is covalent solid, carbon in the term of graphite, diamond, then AlN, aluminum nitride is also covalent solid. So these are the examples of covalent solid you require to be remember. Examples are important. So in the book also it is available, some examples are there, examples you require to read. Thank you up to this.